Hello, my name is Michael Hoffman, and I'm going to make this little video here talking about similarity and congruence. These are two related ideas, and in particular similarity is very important in trigonometry. What are similar triangles? Well, similar triangles are triangles where corresponding sides are proportional. And another way of thinking about proportional is that there's equal ratios. And that's really what this means right here. A and A prime are the sides of the smaller and the bigger triangle, respectively. So if we take this and divide it by that, we get the same thing as if we take this and divide it by that. B divided by B prime is the same thing as A divided by A prime is the same thing as C divided by C prime. You'll notice that these two triangles here look the same. They have a very similar shape. And that, in fact, is another way of describing what similar triangles are. They are two triangles that might have different sizes, but whose internal angles are all the same. This says angle A. Angle A is equal to angle A prime. So this angle A is the same thing as this angle A prime, and angle B is the same thing as angle B prime. These two angles are the same, so I put a double one on there. And then C is the same as C prime. So that angle, we'll put a triple thing on here, is the same as this. So essentially what it is that similar triangles have the same shape but different sides. So the shape is the same but the sides are different and have this proportionality. Okay? So when we apply this to determining whether or not two triangles are similar, we can either show that corresponding sides are proportional or show that corresponding angles are the same. So either one of these will tell us whether or not two triangles are similar. So let's see. Here I have a set of triangles here, and we're asked which pairs of triangles are similar. Well, in A, I know the side lengths, so I'm going to come down here and I'm going to test the proportions. What we have to do is find out which sides are corresponding. It looks to me like this is the hypotenuse, since it's opposite the right angle here, and this is also the hypotenuse. So these two sides are definitely corresponding, so I'm going to write that ratio down. I'm going to write the bigger one on top just out of convenience. So 15 over 10, and if these are similar triangles, it should be the same as, say, the ratio of the two shorter legs. What are the shorter legs? 9 is the shortest one and 6 is the shortest one, so that should be the same ratio as the hypotenuses, 15 and 10, and these should be the same as the second longest legs, which are 8 and 12. So I'll write 12 and 8. And now you may remember that we can simplify each of these fractions, and they should all simplify to the same thing. 1.5 divided by 10, we can cancel a factor of 5. This becomes, if we divide top and bottom by 5, this becomes 2, this becomes 3. So this is equal to 3 halves. Excuse me, 3 halves. And 9/6, if you divide these by 3, then this is also 3 halves. And if you divide these by 4, you also get 3 halves. So what we have here is a constant ratio. All of these ratios are the same. They all equal 3 halves. So these two triangles definitely are similar. Looking at the next figure now, B, it's almost hard to tell which sides correspond because these don't look like the same shape at all. So I'm guessing these are not similar. But we're going to check the ratios just to be sure. I can tell 6 is the longest side, so that corresponds to the longest side over here, 5. So 6/5 should be equal to the ratio of the shortest sides. It looks like 4 and 3 are the shortest sides. Is this true? It absolutely is not true. You can check either the decimal values or You can try and reduce it, but basically neither of these fractions reduce anymore, so we can already see that these are not the same, these are not equal, so these are not similar. Okay. Now, the last example is C here, and over in this space I'm going to work out whether or not these are the same. All we know is the angles for part C. So it looks to me like we've got to find the missing angles here and here. Now, if I call this unknown angle x, looking at this, I can tell that this plus this must equal 90 because the sum of the angles in a triangle have to add up to 180 degrees. So I know that x plus 42 degrees has to equal 90 degrees. Because 90 plus 90, right? So these two have to add to 90, and then we have to add it to that 90 to get 180. So really I can just write the shortcut that these two have to add up to 90 degrees. Solving, subtracting 42 from both sides, tells me that this is 48 degrees. So I know that x is equal to 48 degrees. So this is equal to that, and therefore, since this angle is the same as that one, these two angles must be the same, so this is also 42 degrees right here. So all of these internal angles are the same. These two triangles are similar because the angles are the same. Now, most of the time when we deal with similar triangles, what we're trying to do is solve for some unknown quantity. Here's an example where I have two triangles that are similar, and we can tell they're similar because all the angles are the same. These two things have the same shape, but one is sort of a scaled version of the other. Now what we can do is just apply the idea that these sides have to be proportional and write down an equation. So d over 4 must be the same thing as 15 over 10. These two ratios must be the same if these are similar. What I do is I simplify this. We had 15 tenths, so I just rewrite this as d over 4 is equal to, and what I did is in case you didn't know, I divided top and bottom of this by 5 to simplify. Now I have 3 halves. What I'm going to do is I'm just going to pick a different color, and I'm going to multiply both sides of this equation by 4 over 1. And that's going to cancel these out. And this is going to cancel out. And what happens is that I end up with the equation that d is equal to 6. Basically, the fact that these two are similar allowed me to write down an equation, which then allowed me to solve for d. And we can also notice something here, which is that sometimes we can see the scale factor. And what I mean by scale factor is that this triangle right here is just a blown up version of this one. So what if I took this and just multiplied it by 1.5? Is 10 times 1.5 equal to 15? 1.5 is also 3 halves, by the way. What if I took 4 and multiplied it by 1.5 times 1.5? I would get 6. 6 is equal to 4 times 1.5. So we say, so the answer is 6 here, right? We solve for the unknown quantity, but we can say that 1.5 is the scale factor. Right? What this means is that this rectangle is 1.5 times as large as that. We just multiply all the sides by 1.5. Now, a special case of similar triangles is when this scale factor is really just 1, i.e. the triangles are the same. Here's one triangle, a congruent triangle, just is exactly the same, but maybe it's in a different orientation. The word congruent just really means the same. And basically what congruence means is that the angles inside are the same. So we have that this angle here would be the same as that angle there. This angle here must be the same as that angle here, and this angle here, angle C, the small angle, must be the same as the small angle here, and each of the corresponding sides are also the same. So we have basically corresponding sides that are equal and corresponding angles that are equal. That's what congruent triangles is. Now, in summary, here's all the stuff you want to make sure you have written down. Two triangles are congruent if they have exactly the same size and shape. Two triangles are similar if they have the same shape but not necessarily the same size. And if we want to test whether or not two triangles are similar, we just test whether or not their corresponding angles are equal, and whether or not their corresponding sides are proportional. Now, here's a little homework problem for you. Turn it in at the beginning of the next class with your homework, with your other homework from the text. You're going to copy this problem down and solve it before class. Okay, go ahead.